Did you ever cut your birthday cake? If yes, why do you need to cut the cake into pieces? Because the cake itself is large and you need to cut into the pieces to distribute that into the guest. So that's why you cut the cake into multiple pieces. And this is the same concept of subnetting. Here the cake represents the network and the pieces of cake represent the subnetworks. And this process is called subnetting. If you are a person preparing for CCNA exam, or if you are working in the IT, or if you are a beginner who is starting everything from the scratch, this is one of the most wanted skill in computer networking industry, that is the subnetting. In this video, we are going to talk about the subnetting. Welcome to the video. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, Chapter number 54. What is Subnetting? Learn CCNA with Irash Academy. I have placed the complete CCNA playlist at the top right corner of the video information bar. In this chapter, we are going to discuss what is subnetting and why do we need to do the subnetting. And finally, we are going to discuss what are the basics of the subnetting. Let's talk about the subnetting. What is subnetting? Subnetting is the process of dividing a large network into smaller, manageable networks called subnets. I hope you remember my example that I said in the beginning of this video about your birthday cake. The cake itself is large and you need to distribute the cake into multiple guests. So it is not practical. So that's why you're going to cut the cake into multiple small portions so that it can easily deliver to guests. And this is the concept of subnetting. Here the cake represents the network, and when you cut that into pieces, the piece represents the subnetworks. And this process is the subnetting. Now another question, why do we do it? Why do we need to do the subnetting? We are doing the subnetting to improve the performance, security and reduce unnecessary traffic. Just imagine you are working in a large company. There are multiple users, so many devices. But when you connect all these users and the devices into a single network, your network itself is very large. It will have poor performance because of the large amount of broadcasting signals. It will have less security because you didn't divide into the multiple subnetworks. And there will be a lot of unnecessary traffic going around your network if it is a single large network. And that's why we prefer to divide your large network into multiple subnetwork. For example, you can use a subnetwork for your finance team, and you can use another subnetwork for your HR team, and another subnetwork for your IT team, and another subnetwork for your marketing team. So in this way, you can divide the devices into multiple subnetworks so that you can easily manage them. You can easily implement the security and it enhances the network performance as well. So let's discuss why do we need to subnetting in details. The point number 1, reduce the broadcast traffic. In a computer network, there are a lot of broadcasting traffic because of the ARP, the address resolution protocol, DHCP discovery protocol, and network discovery protocol. And because of this, all the time there will be a lot of traffic going back and forth in your network. So if you are using a single large network, that means all of your users, all of your devices are connected to a large network. Then there will be a lot of broadcasting traffic. As I mentioned, address resolution protocol, DHCP discovery and network discovery. And because of this broadcasting traffic, your network bandwidth that is required for the actual data transfer, it is getting affected. You will feel that your production traffic doesn't have enough bandwidth. That's why you feel poor network performance in your organization. So how to prevent this thing? How to avoid this kind of problems? For that, we can use subnetting. So this large network that we can divide into multiple subnets. For example, this large network of the organization, I can divide into multiple subnetworks, which is called finance, HR, IT and marketing. And all the finance people devices I can connect to the finance subnet. All the HR people I can connect to the HR subnet. All IT people will go to the IT subnet, and all marketing people will go to the marketing subnet. So in this way, when you divide your network into multiple subnetwork, what is happening? So in the finance subnetwork, whatever broadcast happening inside that, it will stay there only. It will not go to HR, IT or marketing subnetwork. because those are different network. In the same way, whatever broadcast is happening in the HR, IT, marketing subnetwork, it will stay there only. It will not go into the other subnets. So in this way, you are reducing the risk of huge broadcasting traffic. You are going to restrict each network broadcasting traffic in that network only. It never go out of the network. Point number 2, to improve the security. So when you connect all of your devices into a single large network, you cannot implement any security feature between, because all the devices are in the same part of the network. So you cannot implement any access control in between them. You cannot allow or restrict the communication between them. The finance people can access the HR people's computer, printer, and even their data, and the marketing people can access HR people data and other resources, etc. So how to prevent this kind of risk? So to prevent this kind of risk, you can use subnetting. So when you implement the subnetting, you are going to divide the large network into multiple small subnetwork, and you are going to allocate one network for finance team, one network for HR team, one network for IT, and one network for marketing team. And they are entirely different network. And now you can control the traffic between each subnetwork. You can control what are the traffic you need to allow from finance subnetwork to HR subnetwork. You can control what are the traffic you need to restrict from marketing network to IT network. All of this security policy you can implement in your switch itself or in the firewall. So here, using subnetwork enhance your network security and help you to control the traffic between the multiple subnetworks. Another advantage of subnetwork is point number 3, to better manage networks. So when you are using a single large network, it is very difficult to manage as a network administrator, because there is no security between the devices. You cannot implement any access list. You cannot control the traffic between them, and the network itself is large. So it is very difficult to manage the networks. So when you divide your large network into multiple subnetworks, then it is very easy to manage the network. If there is any issue happen in any one of the subnet, then that issue exists in that network only. It will not affect the other subnetwork. And when you realize a problem has happened, it is very easy for you to identify in which subnetwork this problem happened, and you can concentrate on that subnetwork only. The rest of the subnetwork work as expected. So subnetting help you to manage the network in a better way. Point number 4, to efficiently use IP address. Imagine you are the network administrator in your company, and it is your responsibility to manage, assign, design the network for your organization. So there is a new project came, which is the CCTV project. You need to connect 20 CCTV into your network. For that, they need the IP address. So you created one network, which is 192.168.1.0/24 for this purpose. And this is a Class C IP address. And how many IP addresses are available in the Class C IP address? Total, there are 254 valid IP address available. That means totally you can connect 254 devices in this network. But here you are going to connect only 20 cameras, only 20 devices. So the remaining 234 IP address are going to be not used here, and it is going to be wasted because you are not using here, you are not going to connect any other device in this network. So this is an example of managing IP address in an inefficient way. So if you do this thing, that means you are not managing your IP address efficiently. So what we can do here? Here we can do the subnetting to resolve this issue. So your Class C IP address, which is 192.168.1.0/24, you can divide into multiple subnetworks, and one subnetwork you can use to connect your CCTV cameras. And the total number of cameras are just 20 only. So you can create one subnetwork for these 20 cameras. The remaining IP address you can use in another subnetwork. For example, you can create a subnetwork for only to connect printers, or you can create another subnetwork only to connect to access points. So in this way, you can efficiently manage your IP address in your organization. So this is one of the benefit of IP subnetting. Point number 5, to enable network growth and planning. For example, in your organization, currently there is only a single network, which is 192.168.1.0/24, and your office currently available at floor 1 only, and there are 50 users available. So for 50 users, this class is good because there is 254 valid IP address available. You can connect 254 devices. But if your organization has a plan to recruit more people, then you need to expand your network. You need to plan for that. So in this situation, you can use subnetting to plan your network growth. Your current office network you can divide into multiple subnetworks, and one subnetwork you can assign to floor 1, where your current existing 50 users are available. The remaining subnetwork you can assign to the upcoming floors as part of your office expansion. So in this way, you can extend your network into next level for the future. Point number 6, to separate wired, wireless and servers. So if you are connecting all of your devices in your organization into a single large network, then there is no network boundary available for multiple devices. For example, all of your computer, server, CCTV camera, access point, printer and any other devices are the part of the same network. So the unwanted traffic and broadcasting message will go to each and every devices unnecessarily. This will make a huge problem. So what is the best practice? So the best practice, you need to divide multiple type of devices into multiple subnets and separate them and only allow the communication between them whenever it is necessary. So I can use the IP subnetting to divide the device type based on their communication. This large network I can divide into multiple subnetworks. And one subnetwork I can assign to the computers only, another subnetwork for the server, then another for CCTV, another for printer and another for access point. In this way I can design my network. And now you can see I can put the access security between these multiple subnetworks. So that means the CCTV camera traffic, it will not go to the server unnecessarily. The computer network will not send any communication to the access point network unless it is necessary. So in this way I can manage multiple type of devices and communication in my network. Now point number 7, routing efficiency, CIDR and ISP level. Just imagine if you are using multiple networks in your organization. Multiple networks are connected to your default gateway, that is the internet router. So if your network devices want to communicate with the outside the world or to the internet, your router need to manage one database which is called routing table. If your router didn't use the routing table, then the internet routers cannot identify where is your network is. So it is mandatory that you need to add your network in the routing table so that the inside devices can communicate with the internet and they can receive the traffic from internet as well. So in this situation, if you are using multiple different network, then your router need to manage multiple network in its routing table. So when you add more and more different network, this database inside your router is getting increased. So it's need to manage a lot of data. And when you add more data, it is all utilizing these router resources, router memory, router CPU, etc. But if you are using a subnetted IP address, then your router need to only maintain that IP address, the main IP address. That is here 10.10.0.0/16. So when your router add this entry in its routing table, then all of your subnet coming under this main IP address or the main network, it is already included in this entry. No need to maintain each and every network one by one. And instead, what is your main network, that can be added. So in this way, your router doesn't need to manage more network at the same time in its routing table. So it can make free some of its memory and CPU resources. Now let's go to the concept of subnetting. How can I do the subnetting? So before you go to the subnetting process, you need to understand some of the concepts. And what are those? You need to understand the basic of IP addressing. If you doesn't know what is the IP address, then you are not able to do the subnetting, because this skills is required to do the subnetting. And the second one, you need to understand the classes of IP address. How many classes of IP address are available and it is using for what purpose, what is its subnet mask, etc. And the last, you need to know how to convert binary to decimal and decimal to binary. This is the most crucial. So you need to gain all of these skills to do the subnetting. So if you don't know what is all this information, just watch my previous video in this playlist. I have clearly mentioned each and everything about the IP addressing, subnet masking, different kind of classes, and how to convert the binary to decimal and decimal to binary. All are available in my previous video. So just watch it and gain the skill, then you can easily do the subnetting. So here I will give you a short introduction about all of this point. So we will start with the IP address basics. So what is an IP address? An IP address is a 32-bit address divided into 4 octet. It is also called as logical addressing. So this is the example of an IP address. So as I mentioned here, IP address is 32-bit address. So how it's called 32-bit address? Here the first part is 192. Then you can see 168. Then you can see 1, and then you can see 15. And each of these are divided with a dot. So that's why it is saying here IP address divided into 4 octet. So that means this is 1 octet, this is another octet, this is another octet, and this is another octet. So 4 octets are available in an IP address. And it is 32-bit also. So the first octet, it contains 8 bits. Second octet contains 8 bit. Third one 8 bit, fourth one 8 bit, and when you calculate all these 4 8 bit, then it is equal to 32. That's why it is called 32 bits. Now let's see what is subnet mask. The subnet mask defines which part of an IP address belongs to the network and which part belongs to the host. So this is the IP address, and this is a class C IP address. So the class C subnet mask is 255.255.255.0. So in this subnet mask you can see there is 255, 255, 255, and one side is 0. So wherever this 255, it is the part of network, and wherever you can see the 0, this is the part of host. So when you take the same concept into the IP address, you can see here 192.168.1. This part is the network part. This is exactly represent this network part, and this 15, this part, it is representing this host part. In the host part you can assign any IP address from 1 to 254. Normally there are 0 to 255 IP address available, but the first one is 0 and the last one is 255. The 0 you cannot use because it is the network ID, and 255 also we cannot use because it is the broadcasting ID. So what is remaining? It is from 1 to 254. So this is the valid production IP we can use in a computer network. Now let's see what are the classification of IP address. So there are 5 IP address classification which are A, B, C, D and E, and they are given here: class A IP address, class B IP address, class C, class D and class E. Here the class D IP address, it is using for the multicasting purpose, and class E IP address which is using for experimental purpose. So we are normally not using class D and class E IP address in the production environment. What we are using is the class A IP address, class B IP address and class C IP address. So if you see the first octet, if it is coming from 0 to 127 of any IP address, then that is a class A, and if it is coming from 128 to 191, then it is class B IP address. If the first octet of the IP address is from 192 to 223, that is class C IP address. And here you can see also the subnet mask of class C IP address. Only one portion is network, remaining 3 portion is for the host. And the subnet mask for the class B IP address, you can see here the 2 portion indicate the network and 2 portion indicate the host part. And the subnet mask of the class C IP address, you can see 3 portion indicate the network and 1 portion indicate the host. So these are the different classes of the IP address. And if you want to know more about the classification of the IP address, you can go and watch my previous videos, which is clearly mention all the detail about the IP classification. Now let's talk about the binary to decimal and decimal to binary conversion. So binary to decimal conversion, this is the binary number 01100011. So how to convert this binary number into decimal? So to do this conversion, we need to bring a binary reference table which is given here. So let's see how to convert this binary number into decimal. So here you can see there are 8 bits in this binary number, and just distribute the 8 bit into our table. So I'm starting from the right side. First one is 1, then 1, 0, 0, then 0, 1, 1, 0. So after you map this binary number into our table, just take the value of all the ones and avoid the values of 0. So here I am going to take the values of 1, which is 64 here. Then we have 32 here. Then we have 2 here. Then we have 1 here. So after we get all the values of 1, just add them all together, and that is the value of your decimal. So here your decimal value is equal to 64 plus 32 plus 2 plus 1. That is 99. This is our answer. So the decimal equivalent of this binary number is 99. Now how to do a decimal to binary conversion? So what is our decimal number? It is 110. So how to convert this decimal back to the binary? For that we need to get our binary reference table. So let me bring it on. Now we have the decimal number 110. So in this table, just see what are the position we need to take to reach the decimal number 110. So I am going from here from left to right. So my value is 110. The first parameter is 128. So it is very bigger than the 110. So I cannot take that. So I consider this 0. Then let me go to the 64. To get the value of 110, I can take the value of 64. So I will mark it as a 1. So 110 minus 64 is equal to 46. So I need to get the value of 46 more to reach 110. So let me go to the next one. It is 32. Is the 32 coming under 46? Yes. So I will mark this as 1. So 46 minus 32 is equal to 14. So I need to get 14 more points to reach the value 110. So let me go to the 16 here. So here the 16 is bigger than 14. So I cannot take that one. So I will consider as 0. Then when I go to 8, this 8 is coming under this 14. So I will consider this as 1. So 14 minus 8 is equal to, so I need to get 6 more points. So let me go to the next one. It is 4. I can take it because it is coming under the 6. I will consider this and make it 1. Then 6 minus this 4 is equal to 2. I need 2 more points. So next one is 2. I can take it because here I need exactly 2. So I will take this 2, and then the remaining is 2 minus this 2 is equal to 0. So the next one is invalid. It's not required. So I can make it 0. So the binary equivalent of my decimal number 110 is equal to 0110 1110. So this is the answer. This is how you convert a decimal number into binary. Now let's see what is the basic of subnetting. To make you understand this, let me take one IP address which is 192.168.1.15, and this is a class C IP address. So its subnet mask is 255.255.255.0. So if you are using this class IP address, you can get total number of devices 255 devices, okay, because this is a class C IP address. But all these 255 IP address you cannot use because one IP address will go as a network ID and the last IP address will go as a broadcast ID. So you can use from 1 to 254 IP address in this network. So if you didn't do the subnetting, you can use this class C IP address as a single IP address, and all the devices will be a part of this network. All these 254 devices. There is no division, there is no boundary, there is no classification or subnetting anything. But if you are going to do the subnetting, you can divide this class C network into multiple subnetwork, and you can manage your network very well. So how to do this subnetting? So let me take the IP address here, and instead of this subnet mask, let me convert that subnet mask into binary. So I can write the subnet mask 255.255.255.0 into this format. Here what I did, I just converted this decimal number into binary. So this 255 I converted into 8 ones, this 255, this part, this 255, this part, and the last part is 0. So all this part is 0. So this is the binary version of the subnet mask. And here wherever you can see the 1, this one, this one, and this one is the part of network, and wherever you can see 0, this part, it's part of host. So when you give multiple IP address into devices, it is going to add to this host part. This is what it is getting changed, the IP address, but the network part remain the same. Here, what is the concept of subnetting? The concept of subnetting is you want to divide your network into multiple networks, right? Yes. If you use this form exactly as it is, the subnetting is not happening because you will get a single host portion and that will be included all of your host part. All the 254 devices will be that part of this network. So to divide this network into multiple subnet, you need to sacrifice some of your host portion. For example, all of this your host portion. It is designed for host. So you need to sacrifice some of the host portion. For example, I can say 3 bits from the host portion I can give to the network part, and only the host portion will be this part. So in this way I can sacrifice some of the bits from the host part and donate that to networking part. And this is the concept of subnetting. And here you can decide how many host part you need to sacrifice depends on your requirement. So here I am going to sacrifice 2 bits from the host part, this part, and this will go to the network part, and remaining 6 bits will be a part of the host part. So here I can rewrite the subnet mask again as follows. So here, as I mentioned, 2 bits I have sacrificed and donate to the networking part. So all this part is indicating your network and this part indicate your host. So you can write your new subnet mask as 255, 255, 255 and 192. As you can see here, before it was 0 and now it is 192. So this is your new subnet mask. And how did you get this 192 here? So this was the last part of the subnet, which is the host part. And here you can see I have borrowed 2 bits from the host to the network. So when you write here in the decimal table, you can say 128, 64, 32, 16, 8, 4, 2, 1. This is my decimal table. Okay, decimal table. So just map this host part into decimal table, then what we are getting? 1 is here, then 1, 0, 0, 0, 0, 0, 0. This is what we are getting. And just calculate the value of each one. So here 128 and then here 64. So just add this together, these two together, then you will get exactly this 192 as an answer, and this is the 192. And remaining all this part is went for the host part. So this is the concept of IP subnetting. So in this chapter, we only discuss the theoretical part of the subnetting. From the next video, I will show you how to do the subnetting in real IP address in real world. So this is the end of the video. So in this chapter, we talk about what is subnetting and why do we need to do the subnetting. And finally, we discuss about what are the basics of the subnetting. Thank you very much for watching and subscribe to the channel for more videos. Enhance your skills using iRash Academy.